Hi, welcome to Rubin Engineering. My name is Engineer Rayford. I welcome you to solving the bedding stresses. So here we have a masonry pile that is of 3 by 4 meters that supports a vertical rod of 80 kilonewtons as shown. This is our rod. It is 80 kilonewtons, and the pile reads 4 meters by 3 meters. The distance from x-axis to the rod is 0.5 meters, and the distance from y to the rodding is 1 meters. So as we all know, if we have the formula for maximum bedding stresses at every corner, which is P over A plus or minus mx y over I x, where P is the rod, A is the area, mx is the bedding moment on the x side, and y is the y bar, the centroid of the y section, and ix is the moment of inertia on the x-axis, and we have plus or minus my bedding moment on side of y multiplied by x bar all over the centroid of x all over I y, where P is equals to the rod, and we have been given the rod as 80 kilonewtons, so we just say P is equals to 80 kilonewtons, where A is equal to area, which is 4 times 3, which is going to give us 12 meter squared. From there we have our mx is equals to P eccentricity at x, that is P multiplied by ex, where ex is the distance from the x-axis to the rodding, which is going to be equal to this from here to here, which is 0.5 meters, and we have P is equals to 80, so 80 times 0.5 is equals to mx is equals to that, which is equals to 40 kilonewton meters. We also have my, which is equals to P multiplied by ey, that is P multiplied by ey. Ey is the distance from the y-axis to the rodding, which is 1 meter, and we get ey, where ey is equals to 1 meter and P equals 8 kilonewtons. So mx is equals to 80 times 1, which is equals to 8 kilonewtons meter. From there we have the formula. We have the moment of inertia ixx, which is equals to bd cubed over 12 for a rectangular section. We find it using this formula, that is ixx, and iyy we find it using db cubed over 12, which is equals to our b is the breadth, which is 4 meters, So there we have 4 meters multiplied by our D is the depth of the column of that pile, which is multiplied by 3, then it is cubed all over 12. Since this is cubed, it means that we have meter times meter times meter. So the answer we're going to get is going to be in meters power 4, since this is 1 meter times 3 meters, which is 4 meters. So this gives us 9 meters. And here we have this, which is going to be 3 multiplied by 4 cubed over 12, which is going to give us what? Let us calculate and see. 4 multiplied by 3 cubed divided by 12, just giving us 9. So that tells us it's correct. Power meters power 4. Then there we have 3 times 4 cubed, which is equals to 192 divided by 12, which gives you 16 meters power 4. So from that we can calculate the stresses at point A, where our point A is this one. If we consider that, we'll see that our Y is on the, it's advantaged by the load, so it is going to be a positive. So on our formula, on the side of Y, we will find that Y is going to be a positive, and on the side of X, it is going to be a negative. So if we incorporate our formula, stresses at A is equals to P over A minus mx y over I xx plus myx over I yy. And we didn't find our x and our y. From our diagram, the centroid of the depth on the x bar is going to be 3. X is equals to be 3 over 2, which is going to be given as 1.5 meters, and y is equals to 4 over 2, which is going to give us 2 meters. So if we fill what we have, it is going to be 80, our P, which is 80 kilonewtons. Here it is, 80 kilonewtons over our area, which is 12 meters squared, minus 8 times 2, since y is disadvantaged. If you look at, the loading is favoring the side of x, but the side of y is just, the x is close as compared to y to the loading, so that makes it a negative, times 2 over 16 plus 40, that is times 1.5 over 9. This is going to interpolate. I just disarranged it. This one is there and this one is this. So our answer is going to be equal to positive 3.3 kilonewtons per meter squared. That is the stresses at B. Stresses at A. Stresses at B is equals to be P. If we look at our B, where it is where the loading lies, so everything is gonna be positive. Our A, when you look at it, the side of X was having nothing, but the side of Y and something. You see, the side of Y, this was empty, that making it a negative, and the side of, the side of X was having, the side of X was negative, the side of Y was positive, giving us our solution to be this. So from our B, everything is, when we look at our B, everything is on the rolling, so everything is an addition. So everything on the side of Y is an addition, so it will be P over A plus M X Y all over I X X plus M Y X all over I Y Y. Everything is going to be positive since the loading lies on that point, you see. So everything on the B is going to be, that is going to be positive, which gives us 80 over 12 minus plus everything is positive, plus 40 times 1.5 all over our x plus 9 plus our myx, which is, let's fit the value, 80 times 2 over 16, which is going to give us what? 23.33 kilonewtons per meter squared. Stresses at C is equals to B over A. If we look at our stresses at C, we will see that My is disadvantaged, since if Mx is disadvantaged, since if you look the side of X, the X, you will lead them from this side going this way, you will see there is no loading. But if you look the side of Y, you will see that this is the side there we have the loading while going this way, so the loading is here. So the side of Y becomes a positive and the side of X becomes a negative. So P over Y minus mx y over I x x plus my x all over I y y, which is going to give us 80 over 12 minus 40 times 1.5 all over 9 plus 80 times 12 all over 16, which is going to equal to 10 kilonewtons per meter squared. And there we have now our D, stresses at D, which is equals to what? If you look at D, the side of X is disadvantaged. There is no loading on the side of X. On the side of X, as we go this way, there is no loading. On the side of Y, there is no loading. So everything turns to be negative, and it gives us P over A minus M X Y over I X X plus mxy plus myx, okay, over iyy, which is going to give us 80 over 12 minus 40 times 1.5 over 9 minus 80 times 12 all over 80 times 2, I mean this is the y bar, 8 times 2 all over 16, which is going to give us negative 10 kilonewtons per meter squared place. That is how we solve the bedding stress. On our next lesson, we are going to calculate the what additional load we should be placed on this, on this pier, so that there will be no tension, and then we will then again going to see the stresses at the corners when the additional load is added at the center. Thank you for attending on this tutorial. Welcome again. Please subscribe and share for more videos we are going to upload. Go on, subscribe to our page and tap on the bell so that you can be updated whenever we give an engineering video. Thank you and welcome again.